All right, thanks for coming. Today we're gonna continue where we stopped the last time. Please make sure you subscribe to my channel. That will help me a lot. Now, last time we did addition. Today we're gonna do subtraction. But before we continue with subtraction, I brought you some images to help you understand the what is called base 10 system, right? That's what the Western world uses. Okay, now see, these are the units right there, and then here you have thousands, millions, billions, trillions, and so on. The units are right here: ones, tens, and the hundreds, right? Ones, tens, hundred, right? And the units are repeated. Notice this: the units are repeated everywhere, right? Under thousands is repeated. The units are there. Millions, the units are there. Billions, and so on, right? To understand this, what they have to do with that way, why the units are everywhere, you have to realize that the base 10 number system, the position, the value of a digit is determined by its position in the system. Another way to say it is the position of the number, any number, determines its value. You understand? So let me give you one example and then we'll go to subtraction. Let's say I tell you to find what is the value, right? What is the value of 7 in the following number, right? In the following number, 38741864015. What is the value of 7? 7 is right here. See 7 right there? 7 is right here. Okay, based on the position, right? These are the units, right? These are, the 0 is on the hundreds, the 1 is on tens, and the 5 is ones, right? These are thousands, these are millions, then the billions, right? So, because 7 is under millions, right? And then the position is on the hundreds. The hundreds, under hundreds of the millions section, right? Then we'll say that 7 represents 700 millions. That's what 7 represents. 700 millions. We usually see that's how we write it, like that, But anyway, here is another example. He said, what is the value of 3 in the number 4,634? Notice that 3 is under tens position, right? So 3 represents 3 tens, which is equals to 30, right? Now let's go to the other one. One more. What is the value of 4 in the number 304,102? Now you proceed the same way. Where is 4? 4 is right there. Notice that this represents thousands, right? Thousands, right? But under 1,000, 4 is located in the ones position, right? So there are 4 1,000s, right? 4 1,000s, right? So that's the position of 4 right there. 4 is basically, 4 represents 4,000. All right, I'm gonna make the following 2 observations before we go over to subtraction. Now notice something. When you go from right to left, right, in the base 10 number system, if you go from right to left, each position is bigger, 10 times bigger than the position you left from. So if you go from 1s to 10, right, It's like you multiply by a factor of 10. If you go from tens to hundreds, it's like you multiply by a factor of 10, right? You multiply by 10, you multiply by 10. That's what the paragraph here, the little paragraph here is saying. All right. The second comment I want to make is it's an implication from the number one, the comment number one I made over there. So when you carry over, remember when we did addition, we carried over, right? When you carry over 1, you're actually carrying over 10. When you borrow 1, you're actually borrowing 10. So keep that in mind. It's from the fact that each position, you move from one position to another, is multiplied by a factor of 10. So when you borrow from one position to another, you borrow in 10. But we usually say we borrow 1. If you borrow 1, it turns into 10, right? So keep that in mind. Keep that in mind, when we're gonna get into subtraction now. All right, we're gonna do subtraction now. When you subtract one number from another, what is that you're doing? Subtracting one number from another means is the opposite of subtraction. Is the opposite of addition. It means you're undoing what addition did, right? For example, let me give you an example. You remember during the addition we said 24 plus 36 is equals to what? It's equals to 60, right? It's equals to 60. That's what we said. That's the result. But check this out. If you say 60 minus 24, you get 36. If you say 60 minus 36, you get 24. So subtraction undoes what division did, right? What is the symbol of subtraction? That right there. You just draw that thing there. The result of subtraction, when you subtract one number from another, the result is called the difference. It's called the difference. That's all you need to know. Don't worry about what the other ones are called. And then another thing, subtraction is not commutative. Subtraction not commutative. Remember that. So what that means is, it's not commutative means you cannot say 60 minus 24 is the same as 24 minus 60. You cannot switch it around like that because subtraction is not commutative. Addition is commutative. You can switch the number, but not with. So the position of the numbers matter. In addition, the position do not matter, so you can switch it around. But in subtraction, the position matter, right? We can write the process of subtraction the way we did with addition. Instead of saying 60 minus 24, and then we'll write 36, right? We'll do it like this. We'll say 60 minus, then we'll write 24, and then we'll draw a horizontal line, then we'll start doing the operation. Right? It makes things easier. That way you don't get confused, because when you have like digits that have you're subtracting 2 digits from 3 digits or 5 digits, this is very the horizontal, this is the vertical. The vertical operation is better. It helps you to maintain the units, the value of positions in the base 10 number system. Alright, so basically to perform this, you say you borrow 1. Remember we were talking about it. Borrowing 1 means you borrow 10. So you borrow 1 from here, call that 5. You put the 1 here, and then you say 10 minus 4, right, is 6. And then 5 minus 2 is what? Is 3. 36. That's how we got that 36 there. So always keep that in mind. Borrowing is borrowing 10. When you carry over, you're carrying over 10. So what I'm gonna do now, I'm gonna do some examples for you. Like I said, you just line things up according to their position in the base 10 system. If you line it up and then put the subtraction sign here, then you're gonna be okay. So let's do the first problem, because I want to knock this out, and then we're gonna go to, I'm gonna do addition and I'm gonna do multiplication and long division together. Then I'm gonna do decimals and fractions and decimals together. Okay, so let's do this one right here. What do you do? The first thing you do, you line it up. Subtract 85, subtract 41 from 85. You line it up. First you write 85, and then you put the sign, and then you write 41, and then you draw that line like that. Organize this way, that way you don't make any mistakes. So 1 subtract from 5, you get 4, right? 4 subtract from 8, you get 4. So that's the solution right there. We'll move on to the next one. This is the next problem. What do? You line things up. Start by lining things up vertically. That way you maintain the base 10 number system positions, right? You want to maintain the proper positions of the digits. 836 minus 741, and you draw that line, and then you start doing the operations of subtraction. 6, take away 1, you get 5. If you take 4 away from 3, it won't work, so you carry 1. You carry 1 from 8, you write it down here like that, and you cross this out and write 7. That way you keep track. So then it becomes 13. 13 take away 4, what do you get? You get 9. Alright, then 7, take away 7 is 0. We usually don't write it. So your answer, we don't write 0 here. Your answer is 95, right? So we keep moving on. So what do? You line things up first. Okay, you say 3, 4, 6, 7, 8. Subtract 1, 4, 2, 1, and then draw that line, alright? And then you do the problem. Take away 1 from 8, you have 7, right? You line things up. Take away 2 from 7, you have 5. Take away 4 from 6, take away 4 from 6, you have 2. Take away 1 from 4, you have 3, and then you bring down 3. Like I said, there's a 0 here, but we usually don't write. There's a 0, it's understood to be there, but we don't write it, you see. So that's your answer right there. So we'll move on to the next one. The next one is 67,481 minus 2,934. What do? You line things up first. You say 67481 minus 2934. See how I'm lining the number according to the value in the base 10 position system. You line it up like this, and you start doing the operation. Now, when you take away 4 from 1, you can't. So you have to borrow 1 from here. You take away 1, you put 7, cross out 8 and put 7, then put the 1 here. That 1 becomes 10. 10 plus 10 plus 1 is 11. 11 minus 4 is 7, right? And then you say 7 minus 3 is 4. Alright, now we'll have problem here. You can't take away 9 from 4. So you borrow 1, you cross this out, put 6, you put 1 here, then it becomes 14, right? 14 minus 9 is 5. 6 minus 2 is 4. And then you bring 6 down. There's 0 here, but we don't write it down. So your solution is right there. So we'll move on to the next one. Yeah, we'll keep moving on. Because I want to knock this out and go to something else. Now, you are told to subtract 9,929 from 49,973. So what do? You line things up first, right? You say 4, 9, 973 minus 9929. You draw the line. So what do? Take away 9 from 3 is impossible. So you cross these out, write 6, take away 1 from there, it becomes 10, and then it becomes 13. 10 plus 3 is 13. 13 minus 9 is 4, right? And then you continue. 6 minus 2 is 4. 9 minus 9, 9 take away from 9 is 0. 9 take away from 9 is 0. Right? I keep saying minus, but it's the same thing. And then you bring down 4. That's our answer right there. It's 40,044. That's it. That's your answer right there. So what's gonna happen? Let me move on to something else. Yeah, let me move on to something and move on to addition and long division. Not addition, but multiplication and long division, okay? Yeah, please don't forget to subscribe. By subscribing, you're supporting me, okay? Thank you. Bye.